works, everyone eventually gets better, but poor Gwen, no. And right away, we see a little bit of a controversy coming up here. The Goblin is taunting Spider-Man, saying, "Romantic idiot, she was dead before your webbing reached her. A fall from that height would kill anyone before they struck the ground." Which, if this were true, the implications for skydivers or bungee jumpers suggest somebody's not telling us the truth about something, but nevertheless, this has been a long-standing recurring controversy among comic book fans. Was it the fall that killed Gwen Stacy or the webbing? And in the year 2000, Wizard Magazine, a monthly magazine about comics, listed this as one of the great open questions in comic book history, on the same level as who's faster, Superman or the Flash? The Flash. But to address this, we will turn to physics. We'll start with Newton's laws of motion. The first law, that an object in motion remains in motion unless acted upon by an outside force, a net outside force. If there is an outside force, then there's a change in motion given by the acceleration, and the force is proportional to the acceleration through F equals ma. And of course, Newton's third law, for every action there is an opposite reaction, forces come in pairs. We know that. So, let's do some math. Just the way my students would. Well, we want to figure out how fast Gwen is going. We know she's fallen from the top of the bridge. We'll use a simple equation. Distance is average speed times time. If you drive at an average speed of 60 miles an hour, and you drive for an hour, you've gone 60 miles. Right. Well, what do I use for the average speed, though? Because she starts with a velocity of 0 and speeds up due to gravity, and she gets a large velocity at the end there. Well, if I have two students in my class, one gets a grade of 0, one gets 100, the average grade will be 50. So I'll take those two velocities, 0 and velocity, add them together, the average will be velocity over 2. I'll put that in there. The time also is related to how fast she's going and the acceleration that she's experiencing, right? It takes longer for the acceleration, a constant acceleration, to speed her up to this large velocity. You do a little bit of algebra, and you get a relationship that the velocity squared is 2 times acceleration due to gravity times the distance she's fallen, the height of the bridge. Okay? If we say that the height of the bridge is about 300 feet, if we neglect air resistance, which we're always doing in these problems. Yeah, some of my colleagues have a problem with the superheroes. If we know the acceleration due to gravity, g, that's 32 feet per second per second. The height is about 300 feet. I look up the value of 2. Wikipedia. Needs sourcing. We find that she's going 140 feet per second, or nearly 95 miles per hour. Well, how much force does the webbing have to exert in order to stop her? Well, we'll use force equals mass times acceleration. Acceleration is change in velocity over time. I'll bring the time over here. And so this will be force times time, which we call impulse in physics. This is mass times change in velocity, which we call the change in momentum, which in physics we represent by the letter P, because it stands for momentum. Rocket scientist. Well, we know what her change in velocity has to be. She has to go from 95 miles per hour to 0. Let's say her mass is 50 kilograms, which would mean she weighs about 110 pounds. That seems about right. If the webbing stops her in about half a second, then the force it has to exert is over half a ton, which is kind of equivalent to about 10 Gs. And yes, I know there are fighter pilots that experience 10 Gs and survive. They tend to be in padded, reinforced chairs with helmets and neck reinforcement. But this part doesn't require suspension of disbelief. If you tell someone they're going 95 miles per hour, you stop them in half a second at a force of 10 Gs, you'd say, yeah, and they die. And in fact, this is why we have airbags in our automobiles. You're in your car, you're going 60 miles an hour, you hit something, the car stops, but you keep moving. Because an object in motion remains in motion until acted upon by an outside force. That outside force is coming up in a moment. It used to be supplied by the steering column of the windshield. These objects are very rigid, very stiff, so the time of contact is very short, so the force is very large. Look, it's completely governed by this equation. You're going 60 miles an hour, and you have to stop to 0 because you hit something. You don't want that, you shouldn't have hit something. Your mass doesn't change. That's the best case scenario. So this part is completely governed by the collision, and all you can do to change the force is affect this side. Right? Airbags do two things. They spread the force over a larger area, so the force per area, the pressure is reduced, and they deform under contact. They give a little bit. So instead of taking 1 millisecond, maybe it takes 3 milliseconds. That doesn't sound like much, but a factor of 3 longer time means a factor of 3 smaller force that is needed. And a force that would have been lethal now merely knocks you unconscious. So, no, they've invented a beer. So, sadly, the same physics that saves our lives in automobile crashes is also responsible for the death of Gwen Stacy. I wrote this up in a letter, sent it to Wizard magazine, they published it, said, see, physics shows that it was indeed the webbing that killed her, not the fall, and that was that. A few years later, in Peter Parker Spider-Man number 45, the Green Goblin is still taunting Spider-Man over the death of Gwen Stacy, but now he's changed his tune. Now he says, I tried to save poor Gwen, but before I had a chance to reach her, Spider-Man did something incredibly stupid. Despite the speed of her fall, he chose to catch her in that rubber webbing of his. In the next instant, her neck was snapped like a rotten twig. So, it's taken at least 30 years, but at least now the Green Goblin realizes that it wasn't the fall that killed Gwen Stacy, but it was in fact the webbing. I don't know how well I do with my students, or the readers of my book, or with you guys here tonight. But if I can teach a homicidal maniac, then I'll make it a difference. Now, one of the very positive things about all this media attention I mentioned at the start was literally hundreds and hundreds of emails from students and teachers and people long out of college who liked this way of explaining physics using superheroes, asked if I had a book, which eventually led to my writing a book, which is now in the 2nd edition. And so I have one last slide. Please, concentrate, focus all your attention on this last message from the ringmaster of the Circus of Crime.